Hey guys, welcome back to my new video. In this video, we will be learning about the C++ operators. What are C++ operators and its type? So let's begin. Our today checklist is C++ operators and their precedence and their associativity. Now, there are many types of C++ operators. Some of these are listed below. First one is arithmetic operators, second is relation operators, third is logical, fourth is assignment, fifth is bitwise, and some miscellaneous operators. So in this video we will learn about the six types of operators. So let's begin with the first operator. So our first operator is arithmetic operators. Arithmetic operators are the daily basis operations you have learned in our maths class, like addition, subtraction, multiplication, and division. Like if we want to get the sum of two numbers, then we can get it simply by doing num1 plus num2. Basically same for a subtraction. Now for multiplication, here we don't use multiply sign, instead we use star sign. Like we want to get the multiplication of two numbers, we just write a star b, which is similar to a multiply b in max. Now for division operator, we don't use divide here, instead we use a slash b. Okay, now some other arithmetic operations are modulus operator, increment operator, and decrement operator. What these do? Modulus operator give us the remainder of the given two number. For say I said 5 modulus 2, so it will give 1, because as we know, if we divide 5 by 2, the remainder comes 1. So modulus operator always gives the remainder of the two numbers. Okay. Increment operator. Increment operator always increases the number by 1. If we write 5 plus plus, so it will always give 5 plus 1, that is 6. And same here for decrement operator, 5 minus minus equals to 5 minus 1 equals to 4. You can add before or after number, increment or decrement operator, it's upon to you. Now let's begin towards our new operator, which is relation operators. In it we will say about equal operator, not equal operator, and greater than, and many more. Let's begin. In this operator, first one is our is equal to operator. If we want to say that a is equal to b, here we will use a equals to b. This means that a is equals to b. Yeah, if we want to write it's not equals to b, so we'll write a exclamatory mark b. It means a is not equals to b. And if we want to write a is greater than b, similarly in max we can write here simply, no other big thing is here to use. Now furthermore we begin. For less than we can write a is less than b, and if we want to write a is greater than equals to b, here it covers our two situations, that a is greater than b or a is equals to b. Similarly, a is less than equals to b also covers two situations. If a is less than b or a equals to b. Okay. Now as we have seen, our two operators, arithmetic and relation operators in a code. Let's begin toward the logical operator, which are somewhat new to you. First one is logical and first one first one is logical and second is logical or third is logical not. What does this means? Logical and means if we have given a two expressions or the user have given two expressions to the compiler to, so if both the statements are true, then the compiler will execute true. If one of them is false, so compiler will also execute false. Okay, I am again repeating it. If both the expressions are true, so compiler will give us true. If one of them is false, the compiler will execute false. False means 0 and true means 1. Okay, in compiler it will give us 1 or 0, which means true or false. Now begins to our the logical OR. We write logical or with the sign double slash. If we have given two expressions, expression 1 and logical OR expression 2, what does this mean? If both the expression are false, then only our compiler will execute false. If one of them is true, so our compiler will also execute true. Again, I am again I am again repeating it. If one of them is true here in logical OR, so compiler will execute true, but if both of them are false, so compiler will execute false. Now as we seen logical and logical OR operator, now let's begin towards our logical NOT operator. What does this mean? It's a simple thing, not a big thing. If I write logical NOT of true, it's mean opposite of true, which is false. If I write logical NOT of false, it means opposite of false, which is true. So logical NOT is simply an opposite of that word. Okay, here is a thing to note in your copy. That in C++ or computer language, true is always executed as 1 and false is always executed as 0. So don't get confused in these two number if the code gives you 0 and 1. Okay, so our next operator is C++ assignment operator. In this operator we will see very basic things. What a first operator says. These are used to assign the value in C++. For example, if I say int p equals to 4, here e equals sign is used to assign the value of p in C++. Likewise, the if I write a plus equals to 1, it means a plus 1, and if I write a minus equals to 1, it equals to a minus 1, and if I write a divided equals to 1, then it is equals to a divided by 1. And if I write a modulus 1, it is equals to a to modulus 1. Okay, these are the expression or shortcut we can say to write modulus, increment, decrement operators or division operators. Okay, so now let's begin to our new operator, that is bitwise operator. What is bitwise operator? First we will see bitwise complement operator. What is this? This is as similar as logical NOT operator. Here we don't write any string like true or false to get the opposite word. Here we write numbers like 0. If I write opposite of 0 is 1, and if I write opposite of 1 equals to 0. Okay, now let's begin to our next operator, which is left shift. If I left shift any number by 1, so our number will become 0 1 0 1. This number will come here, this will come here, and this will come here, and this will go here. Okay, same here, same like in right shift. If I write 0 1 0 0, right shift 1 by 1, so our number will come 0 0 1. Every number will shift their places to their right ones, and this will come in front. Okay, now you will be asking me that what is this 0 1 0 1? This is the computer language, as we have learned in our further computer classes, that how we can convert decimal to binary. Here I will give a short recap on how to convert decimal to binary. So now guys, let us see conversion of binary to decimal and decimal to binary. If I take a number, if I want to convert 1000 into decimal places, what we'll do? We will take the first odd multiple of 2 power left after it and add like this again and again for second number and so on. What does this means? This means here to convert this, I have to take our first number, which is 1, then multiply it with the 2 raised to the power 3, because there are three terms after it, after the number we have taken. Here we have taken 1, so we will take after this number there are 3 number after 1, so we will raise to the power 3 and add the second number, which is 0, raised to the and to multiply 2 raised to the power number after it, which are 2 1 and 2, so power will be 2, and so on for other number 2 raised to the power 1 plus 0 into 2 raised to the power 0. Okay, so our answer will be 8. So see how easily we converted our decimal to binary and binary to decimal. Now we will see decimal to binary. Now let us see how to convert decimal to binary. For your reference, I am taking same number as we have tried before. We have to convert into binary number. How we can do so? We have to divide 8 with 2 and write the remainder on the left side. As we divide 8, so our remainder comes 0, and the following number we have to divide by 2 and write the remainder on the left side. If we divide 4 by 2, so its remainder is 0, and now If we divide 2 by 2, so the remainder is also 0, and at last we get 1. So we will write from up down to up 1 0 0 0 like this. So our decimal number is 0 0. Okay, let us take another example. Now for example number 2, if we want to convert into decimal place, again we will divide 5 by 2, so the remainder is 1 and the quotient left is 4. If we again divide that 2, so we get 2 and the remainder is 0, and if we again divide 2 by 2, so the remainder is 0 and the quotient is 1. So we will write up to down to up, so our answer will be 1 0 0 1. Okay, so like this we can convert any number from decimal to binary and binary to decimal. Now let's continue our bitwise operator. So our next bitwise operator is bitwise OR. What does this says here? Bitwise OR, if for example I write two statements which are true, 1 and 1, so it will give us 1. If I write two statements which are not same, so it will also give true. If I write both statement false, so it will give 0. Here you can convert it like this. Bitwise OR, here it means bitwise OR states that if both the expressions are true, so it will execute true. If one of them is also true, so it will then also execute 1. But if one of them is false, so it will execute 0. Now let us see bitwise AND. Here same concept applies. Here the same concept applies, that if one of the statement is false, so our C++ will execute with false. If both are true, then only it will give 1. If one of them is false, then it will give false. Okay, now let us do a simple question based upon this. If I write 0 1 0 1 0 and 0 1 1 0, so what will be answer? Here operator uses AND, so if both statements are false, it will also give false. If both statements are true, then only it will give 1. If one of them is false, so it will give false. So the answer by using bitwise operator of bitwise AND in between these two is this. Now let's see what is bitwise exclusive OR. If I write exclusive OR between two same number, it will also always give 0. But if one of them is false, then only it will give true. Okay, it is not great thing bitwise exclusive OR. Like, share and subscribe this video for. Bye bye, see you in the part 2.